All right, here's where I'm going to be going through some of the solutions for some of the practice problems I give. The first one is the hydrogen atom. So basically it's the one proton, one electron separated by the atomic radius, which is 5.3 times 10 to the minus 11th meters. And we want to compare the electric forces and gravitational forces. So if you look at that list I gave in the third video, the electric field video, I'm going to follow that method, that algorithm to solve the problems here. But in this case, we only have two particles, so we don't have to worry about a diagram, and it's just at those points that it's our point of interest. So I want to make sure everything is in SI units, so I need to convert it, make sure we have everything as just plain SI units, not with any prefixes before them. So for the gravitational force, I need the mass of the electron, mass of the proton, which I had in the electric force video, and then the charge of the electron and the charge of the proton are both equal to the elementary charge of 1.6 times 10 to the minus 19th coulombs, and the separation distance from the center of the proton to the center of the electron, approximately, is that 5.3 times 10 to the minus 11th meters. So then we're needing the equation for force, so we have the gravitational force, which is just Newton's law of universal gravitation, g m1 m2 over r squared. Just plug in those values, and then you get this ridiculously small number, 3.6 times 10 to the minus 47 newtons. But now we want to compare that to what we get for the electric force. And so for the electric force, you have those two electric charges, but now the constant, instead of being 6.67 times 10 to the minus 11th, is 9 times 10 to the 9th. So you plug all of that in, and when I plug that in, I get 8.2 times 10 to the minus 8. So if you compare that, that's a difference of about 10, almost 10 to the 40th. So that's, at that scale, you can basically ignore the gravitational force, which is what happens in quantum mechanics when people are studying the properties of atoms and molecules on that small of a scale. You don't worry about gravitation. That's why in chemistry is dominated almost exclusively by electric forces. So that's how molecules are formed. Ions, everything like that is all basically dominated by these electric forces, and you can kind of see why just be looking at that scale. You couldn't even tell the difference between those, that the second force was in existence because the first one was so strong, or the electric force is so strong. All right, now I want to look at the two-dimensional charges. There we had the 5 microcoulomb, I don't know what that is, microcoulomb charge placed at the origin, a negative 5 microcoulomb charged at x equals 2, negative 7 microcoulomb charge placed at y equals 2 meters. What is the force exerted on the charge at the origin? What direction does it point? So if we look at it, I kind of sketched the problem here, red for a positive charge, black for negative charges, and then I found my point of interest. I could have put a dashed line around it and said that's where I'm looking at. I'm looking at charge A. So looking at that, there's going to be two forces. There's going to be a force on A from B and a force on A from C. The AB force, because it's an attractive force, because they're opposite charges, is going to point to the right, and AC is going to point up because it's an attractive force. So now I need to look, so it's 1 and 2. Then I look at my variables, and I need to convert that to just standard SI. So micro is 10 to the minus 6. So we have 5 times 10 to the minus 6, negative 5 times 10 to the minus 6, and negative 7 times 10 to the minus 6. The distances are just 2 meters, so we don't have to do any changes there. So then I'm going to find those two forces. They're the x component and the y component. So now I look at that, 9 times 10 to the 9th times those things, those values, and I get for the AB force, I get 0.05625 newtons. For the y force, I get 0.07875 newtons. And I'm not going to do any rounding yet because we're not at the end of the problem. And then I'm going to draw that out, and if you look at it, we have our x force and our y force. Our x force is just going to be the horizontal component, AB, and the vertical component is going to be AC. So now to find that, just use Pythagorean theorem, and we get, once I've rounded, 0.097 newtons, and then that will be at an angle using the inverse tangent. We'll give it about 54.5 degrees. And so that's how you set up those types of problems. Hopefully that helps you out with the homework. Make sure you get those in by Monday at 2:30. There's also the quiz. Make sure you get all of that stuff done so that we're ready to move on to the next unit. I'm still trying to figure out exactly what we're going to do in terms of testing, but that's the world we live in right now. We're trying to figure out how everything is going to be done.